Surface micromachining. In this one, in surface micromachining, the first one is that inching process creates a 3D microstructures by removing a material from the substrate. That is nothing but removing the material from a substrate. Removal of a substrate material or removal of the substrate materials are wasted. Surface micromachining creates a 3D microstructure by adding a material to the substrate. This one. Next one, added material may not be same as a substrate material. Added material layers can be got a 2 to 5 micrometer thick each. And next one, what I got a there is little waste of a substrate material. Deposition process are commonly used methods. Methods are expensive. Required multiple masks. Requires sacrificial layers to be create cavities. And here the in like this one, let me explain this one. In contrast to what a bulk micro manufacturing technique in which substrate materials are removed by physical or chemical means. The surface micromachining technique builds a microstructure by adding a materials layer by layer on the top of a substrate. The deposition technique in the particular they have been using it as two technique. One is that you got a low pressure chemical vapor deposition, and next one is that a polycrystalline silicon is a common material for the layer material. And sacrificial layers are usually made up of silicon dioxide used in the manufacturing for MEMS components, but are removed to create necessary wide space in the depth. This one that are nothing but they are to be removed to create a respective wide space. There is nothing but they must be whenever you are forming the layer by layer, it must be depth should be maximum. Depth should be maximum. This one. And here in this one, here what you got the overall height of a substrate therefore is no longer limited by commercially available vapor thickness. There is nothing but whatever the commercially available vapor thickness we have been getting, we have been available in the market. That is nothing but it should not be a restriction to the respective the height of the substrate. This one. In some range the thickness should be 2 to micrometer thickness, and you got a 5 to 20 micrometer thickness. And here in this one basically we are going to discussing with respect to so general structure of this one, the process of this one. In this one there are three techniques are there. Surface micromachining device are typically, first one is that sacrificial component, microstructural component, and insulator component. In this one, the first one is that what I got shown in this one. First step, what is that you got? First step they have been making in this one. In first step, what is that you got? They have been making it as a with the silicon substrate base, with the PSG deposit on its surface. That is thing, but with the substrate of you got a silicon on that, it is going to get to be deposited with a PSG material. And second, what you got? Cover the surface. That is the thing, but cover the surface of the PSG layer for the subsequent inching to allow for the attachment of for the future cantilever beam. Whatever the nature of this one we should have to form, it should have to get to be formed as a cantilever beam. For that, what is that we should have to go for the respective cover the PSG layer with the mask of this one for a subsequent inching away the PSG for the beams. This one, what is that this one cantilever beam. This one. Next one, another mask is made. This one, another mask should be made. Another made up of a deposition of a polysilicon substrate. This on a polysilicon microstructure, on the respective polysilicon microstructure. This one. Next one, what I got for this one. Here the produce of a mask to produce of you got a mask to with the opening of a size of a beam length. That is the thing, but with respect to the size of the size of the respective beam. This one. And next one, what I got a deposited polysilicon over the mask region. That is the thing, but over the mask region using a CVDT. This is a technique that can be used for this one. And here chemical vapor deposition. This one. That is the thing, but of the thickness. This one. And next one, the remove the this one. That is the thing, but the sacrificial this one by inching this one. we have to remove this one and creates the free end etching, this one free end free end standing cantilever beam. And here what I got a inching of a sacrificial layer. What are the things that are going to get to be used for? You got a materials PSG, this one phosphorus silicate glass, silicon dioxide, and boron phosphate silicate. These with respect to what a composition they have been using for this one. Tin oxide, this one, how much layer should has to get to be used for this one. Rate for you got a sacrificial layer, this one. It means that we should have to get to be formed layer by layer, this one. And so what are the respective got a chemical problems, this one? The quality of addition of a layer, that is the thing what with respect to got a interface of a layer, there are this one some problems you go to get this one, peeling of this one, and you got a then what is severing along the interface by shear, this one, due to the stress, and you got a up layer by layer there is some problem, this one. Interfacial stress due to the mismatch of this one, due to the mismatch of the chemical composition, this one, during oxidation and after you got a oxidation process. And you got this is the major problem, this one. What I got a stintion in this one, it is the most serious technical problem in the surface micro manufacturing. That is the thing, but with respect to whenever you are forming it as a layer by layer, it occurs in the structure separated by narrow gap that is supported by sacrificial layer. That is the thing, what some narrow gap is going to get to be provided is going to get to be existed, and is the stinction phenomena is the collapsing of a layer supported by the sacrificial layers once they are removed by the inching. Once we are going for the removal of that one, they got some problem will be going to get this one. And stinction may going to occur in the example of a cantilever beam fabricated by surface macro machining, this one. These are the respective layers, this one. And whatever got once a stinction takes place, there will be got changes to the separate parts again. It occurs due to the Vander's law, and you got a chemical forces between the surfaces with the narrow gaps. This is about the surface micro manufacturing. Next we will go and discuss what we got a